In this problem, we need to use the concept of the phasor to combine the following sinusoidal functions into single trigonometric expressions. The time domain form is assumed to be similar to this, and this is what we're going to look at. Basically, in each of these, we are given a voltage here and a voltage here. For these other parts, we're given voltage here, and voltage here, and basically we need to add them all together. However, in the form they're all currently in, we cannot add them together. So we are going to have to change them a little bit, add them together, and then change it again to write it out in our trigonometric expression. We're going to start off with A, and to do A, we're going to break this up into two parts. This is going to be our first voltage, and then this is going to be our second voltage. We know that we can rewrite this as our V of M being 100 for the first one. We have an angle, and then inside of our angle we have 45 degrees. For our second one, we have the VM of 500. We then have an angle, and then we will have a negative 60 degrees inside of here. Now we need to add these together. To add these together, we are going to have to move them into a kind of rectangular form, I think it's called, but they're going to look like this. We are going to have our V1, because this is our first voltage, and then inside of here we will write what we are looking at, which is this part, and we're going to set this equal to, and then outside of two brackets we are going to have our 100. We are then going to have our first bracket, and then inside of here we're going to have our cosine 45 degrees plus j times our sine, and this is our angle still of 45 degrees, and this is enclosed in a bracket. Now we're going to factor this 100 in and write them out. So this is going to be our first equation. Now we're going to do the same thing, but for the second equation, this is going to be our V2, and for this we are going to have our 500 in here, our angle, which we know to be negative 60 degrees, and then we're going to set this equal to the same thing, except with our different numbers. And this is going to be our second equation. Now, since these are basically the same thing, we can add them together. If we do this, adding our first part to our second part, we're going to get 320 minus j times 363. Now from here we just need to plug this, because we've added them together, back into this form. However, we're going to need our V max. To calculate V max, we are going to say that our V of M, and this is a formula, is equal to the square root, and then we're going to do the V, which is this 320, plus our 363, both of them being squared. So we have the square root of 320 squared plus the negative 363, this is squared, under the square root. This is going to give us approximately 484. And now we can solve for our phase angle. And our phase angle we're going to find from our theta being equal to tangent of -1. And then inside of here we are going to have what we are looking at. We want to convert this part. So we will have our negative 363 divided by the next part, which is 320. Making sure this is in degrees because our output is going to be in degrees, and this will give us approximately negative 49. So now we can plug both of these back into their respective spots. We know that our 484 is going to be our VM, and this goes in front. So we will have a 484 here, and we know that our theta, the degrees, is going to be the last part. So we will have a negative 49 degrees here. And that is how you would solve this first part, part A. Now I'm going to get rid of this and move on to part B. For part B, it's going to be the exact same thing. However, we have something that we need to convert. Whenever we do this phase combination, we are always going to do it in cosine because it is easier. And we can only add things that are of the same type. So we cannot add a cosine and a sine together. So what we're going to have to do is pay attention to our sine and convert this to a cosine. The way that we are going to convert this to a cosine is by doing the following. We know that our VM is going to be the same, so we are going to have a negative 150 regardless. We know we are going to convert this to a cosine, so we'll have a cosine out front, and then our omega is going to be the same, our t is going to be the same. The only thing that changes is our degrees. And if we look at a graph, I'll just draw one out here real quick. We know that our sine starts here, and then it waves like this. We know that our cosine starts right here, and it will wave like this. Well, if our sine's max is right here and our cosine's max is right here, our cosine is kind of lagging about 90 degrees behind our sine max. So what we can say is that we know that our sine is 140, and if our cosine is 90 degrees behind it, we will then have a 140 degrees minus 90 degrees, and this will give us a plus 50 degrees. And that's how we would write this new equation. Now we need to find the voltage in degrees for this first part. So for our V1, we're going to get our Vmax to be 250 and our angle to be 30 degrees. For our V2, which is this part right here, we're going to get that our V2 is our negative 150 with the phase angle of 50 degrees. And now we're just going to plug both of these into the equation. I'll write it out once here, where we have our Vm out front, and then inside of here we're going to have the cosine of our angle plus j times the sine of our angle, and then we're just going to factor this and solve for both of them. Once we have both of these, we are just going to add them together. From here we have this. Now we just need to convert it back into the form that it's asking for us right here. To convert this, we are going to use our Vm and set that equal to the square root with our first part, this 120.5 in it, squared, plus our second part, which is the 10, and this is also squared. And this is going to give us a Vm of approximately 121. Now we want to find our theta. This is going to be measured in degrees, so this is going to go right here. And our theta is going to be equal to our tangent minus 1. And the first thing that we're going to plug in is the actual part, the j part, which is 10. And then we are going to have our 120.5, and this is going to give us a theta of approximately 4.7. However, due to some rounding that we did up here previously, it's a little bit lower than what it should be. Instead of being 4.7, it should actually be 4.8, and that is just because of rounding error. But if you kept the values from earlier, you'd probably get 4.8, and that is correct. And that's how you would do the second part of this problem. Now we are going to look at part C. In part C, it is very similar to parts A and B. However, we just need to convert this sine part into cosine, because again, we need everything to be in cosine. And just so we don't lose track of everything, we are going to label this V1, this is going to be our V2, and this is going to be our V3. First, I'm going to convert our V2 so we can actually look at it. We know that it's going to be a negative 120. This is going to change into a cosine, and then inside of here we are going to have our 100t, and then we will have currently we have a negative 125. Remember that our cosine is about 90 degrees behind our sine, so we're just going to have a negative 125 minus 90, and this is going to give us approximately negative 215, and this is in degrees. Now, to start this off, we are going to kind of forget about this right now and just look at V1. We know that our V1 is going to have our Vmax, which for V1 is 60, and then we are going to have the angle of 60 degrees inside of here. We can set this equal to 60. This is the Vmax, and then inside of here we are going to have the cosine of our angle, which is 60 degrees, plus the j times sine of our angle, which is 60 degrees. And then we are closing this off. And then we're going to do the same thing for our V2 right here and our V3. Now, writing out all of these equations, all we need to do is plug these in, factoring out our Vm's in front. And after we do that, we're going to get these values here. So in our first column, we're going to add 30 and our 98 and our 0. And from this, we are going to get approximately 128 plus, and then our j. And then this part we're going to add our 52 plus our negative 69 plus our 100. And this is going to give us 83 approximately again. Now for here, we've added everything together. Now we just need to find our Vmax and our theta. So our Vmax we know is going to be the square root of the first part, which is 128 squared, plus the squared of our second part, which is 83. And from this, we're going to get approximately 152. Next, we want to find our theta. And we know our theta is going to be equal to our tangent negative 1 over our j, which is going to be 83, or over the part that's with our j, not our actual j. It's just the part with it, so we're going to have the 83 over the other part, which is 128. We can see how first we analyze the 128 for our VM, and then the 83, and then we do the opposite. We can think of this as our VM has to come first. So we are going to add just this part that is out first, and then we put our second part in. And then our theta, it's behind our V of m, it's right here. So we want to have our second part, just like our theta, up first and then over our V of m. And this is going to give us the theta of approximately 33 degrees. And that is the answer for part C. Now we're going to move on to part D. For part D, we have three parts again. We are going to have our V1, our V2, and our V3. They're all cosines, so we don't have to convert anything. So that's pretty good. We just have to add everything together. So I'm going to write these all in their separate equations, but I'm going to show one and then everything else is basically the same. So for our V1, inside of here, we are going to have our V of m first, which is our 100, and then we are going to have our angle, which we know to be 40 degrees, and this represents the entire V1. Now for this, we are going to put our Vm, which is the 100 out front, and then inside of here, we're going to have the cosine of our angle plus j times the sine of our angle. And then we're going to repeat this for V2 and V3. I made a mistake right here, and I corrected it. It should be 40 degrees, not 45 degrees for these. And now from here, we're just going to factor our VMs here and make sure the calculator is in degrees. And then we are going to add everything together. And then we're going to get approximately all of these values. Now we can add them together. We're going to have our 76.6 minus the 94 plus 17.4. And then this is going to give us a 0. Now we're going to have a plus j. And then in this part, we're going to add our 64.3 plus our 34.2 plus our negative 98.5. In doing this, we are also going to get 0, so that's pretty good. This probably means that these answers are 0, but it's good practice to go about and actually solve them anyways. So to find our Vm, we're going to set this equal to the square root of our first part, which is 0 squared, plus our second part, which is also 0 squared. This is going to give us a 0, so we know our Vm is for sure 0. We're going to do the same thing, but for our theta. We're going to set that equal to the tangent -1 of our second part, which is 0, over our first part, which is 0. And since these are rounded, they're not actually 0. They're almost 0. Again, they're not actually 0 because if we were to divide this by 0, we would get an error. So remember, these are all rounded. This is rounded, and this is rounded, and so even as this is rounded. So it's not exactly 0. So we are not dividing by 0. Super important to never ever divide by 0. But we can say this is super close to 0. So we can say a super small number is divided by another super small number, and then this is going to basically give us a theta is equal to tangent -1 of 0. And the theta for this is going to equal 0. If we plug a tangent -1 with a 0 into it into a calculator, this is going to give us 0. So our answer for this part is also 0. And that's how you would go about solving for this problem. We have the work for A, B, C, and D here, and that was super long, but also super important because we kind of did 4 problems in one. If you want more introduction to circuit analysis or phasor concepts, there is a playlist and notes for this entire coursework in the description below.